Hi class, let's take a look at problem 12. Now, for the rest of the problems, they're a little bit short, but we have to be very careful as we approach them, especially as fractions get canceled. And the basic idea is still the same. We're going to be adding both of the fractions. And also, if you notice that some of the fractions reducing before you go further, it'll make the problem's a little bit easier. So what I'm going to do on this one is I'm going to reduce the second fraction. So this is equal to 3/5 minus, and the 9, I'm going to express it as 3 times 3, and then the 15 as 3 times 5. And the 3's cancel. So as we rewrite this fraction, we're looking at, this is equivalent to 3/5 minus technically 3/5. So notice that, well, you're subtracting the same quantity, so we end up with 0. On this particular one, the entire fraction cancels out. It's like having 2 minus 2, except that they didn't give us the 3/5. It was actually as a fraction, not reduced. So that's it for problem 12. And as I mentioned before, it's just easier to take a look at it before you start getting an LCD to cancel any fractions that reduce. So let's move on to problem 13. And same idea on problem 13. Notice that this one actually reduces further. So let me rewrite it as, this is equal to 1/4 plus, and this will be 2 times 3 and 2 times 4. And then at this point, 2's cancel. So we're left with 1/4 plus technically 3/4. And notice that, well, we already have an LCD, so this is just 1 plus the values of 3/4, or 4/4, or the values of 1. That's it for 13. Once again, it reduced, so no need to create an LCD. That would have taken a little bit extra work to simplify it. Let's move to the next problem. And we have the same situation. The fraction reduces. So let me just rewrite it as, this is 2 plus, and well, this will be a 2 times 5, and the 12, we can express it as a 2 times 6. And then we can cancel the 2's. So we're rewriting it as 2 plus 5 6's. And then at this point, unfortunately, we're going to have to get an LCD. So our LCD is equal to 6. So multiply times 6 and times 6, the first fraction. So this will give us, well, the values of 12 6's plus 5 6's, or the values of 17 6's. And I'm going to leave it as a fraction. They did not express the original problem as a mixed number, so I'm just going to leave it as an improper fraction. Let's move on to problem 15. And in problem 15, we have to be a little bit careful. For instance, we have a 9 in the denominator, so we already have a common denominator. So this is equal to 8b plus 3b, technically over 9. And now we'll do the following step of reducing, or in this case, simplifying the numerator. So for this particular problem, we're just going to end up with 11b over 9. So we're treating the b as a variable, and it remains on the numerator. The b's don't cancel since there's no b at the bottom. So that's it for that one. Nothing else to do since we already have an LCD. Let's move to 16. And good news on 16, we already have an LCD. So this is 7 plus 9, and we're looking at, well, p at the bottom, or 16p. Now I'm going to box this one in, and let me technically just do an extra step because some of the problems on the homework may be asking for this. So you end up with a fraction, but this fraction is only true if the values of p is not equal to 0. So I'm just adding that extra part. Some of the problems on the homework may be asking for this portion, since technically you cannot evaluate 0 at the bottom. That would be undefined. Notice that on the previous one, you have a variable on the top. You could have a variable on the top, because if that's 0, it's just going to make the whole thing 0. Similar like to problem, I think it was the first one. 3 minus 3 cancel out, and we ended up with a 0. So you can have a 0 on the numerator, but you cannot have a 0 in the denominator, since technically that would make the fraction not defined. So on this one, I'm just going to express it as 16 over p, or technically 16 over p with the disclaimer that the denominator cannot equal to 0. Let's move on to the last problem of this set, and that's going to be 17. And none of the fractions cancel. We're going to have to get an LCD. Now, your LCD is going to have a 3, a 5, and a b, since it happens to be at the bottom. Or in other words, 15b. So let me rewrite the fraction, and this is 2 over 3b plus 4/5. And then I'm going to multiply times 5 the first one to get the 15b, and then times 3b on the second one. And then before we merge them, we have to check that we do have the LCD. So in this case, we have 10 over 15b plus, well, 12b over 15b. And before we add them, we technically have to have the 15b at the bottom. Now, on the top, we leave it as 10 plus 12b over 15b, and that's going to be our final answer. So this is one way to express the answer. The second one would be by expressing the 10 plus the 12b over 15b, and technically b not being equal to 0. That would be another way to express it. Let me just rewrite this one in another form, because it is possible that they're asking us to try to factor something from the top. So this is just an extra step that I'm going to show you here. It may not be needed in these problems, but later on they are going to want us to extract values from the top. So for example, I see a common 2. So in this case, this is equivalent to 2 times 5 plus 6b over the values of 15b, such that b is not equal to 0. So this is just another way of expressing the fraction, and that's by factoring a common factor on the numerator. Since you ended up with the sum and you cannot combine these because this one has a b, then the only other step that could be taken would be to extract a common factor. In this case, the 2, because 2 times 5 is equal to 10. 2 times 6b, that would be the 12b. So I'm just giving you on this last problem all the possible ways that your solution could look like. For this module, this would be fine. The first one that we boxed in. That's actually it for this set of problems.